Hello everyone, welcome to this session. Get started with machine learning on IBM using free open source technologies. So I'm Benoît Marolo, architect at the Systems Center in Montpellier. If you have any questions, don't hesitate to contact me. So let's get started. In the agenda today, machine learning, a quick introduction. We will talk about use cases and then we will focus on solutions. And I will proceed with a demonstration involving Scikit-learn, a very powerful machine learning library that you can run on IBM and AIX to build predictive machine learning models. So if you want to go further or if you have any questions, don't hesitate to contact me after this session through LinkedIn or email. So first, a quick introduction, and we'll talk about use cases. Why would I use machine learning on my IBM platform? So machine learning is everywhere. You are not necessarily aware of that, but when you use Netflix or Waze, behind the scenes, machine learning models help these applications personalize your experience to make some recommendations based on your habits and based on historical data and statistics. Machine learning, again, is everywhere. And governments, public institutions use machine learning and statistics to build predictive models. In that particular example, we used a particular dataset collected by the Johns Hopkins University to build predictive models to get more information about the epidemic's progression. Another example, by using machine learning applied to unstructured data and images. This to know a little bit better this virus at the molecular level. And this is a way to automate things and make better analysis based on images coming from microscope using the best of breed HPC computing platform running on power with machine learning algorithms detecting patterns on pixels. So what is machine learning in fact? Machine learning was invented in the 50s. It relies on computing power, mathematics libraries, and data. And the good news is we have the three affordable and available right now. These kinds of algorithms learn from data. There is no explicit programming. You give to these algorithms the data, historical data, with all the characteristics of the phenomenon you are observing. You train this model, help it recognize patterns inside this data, so it will be able to recognize things on new data coming from a production system and help you make better decisions. These algorithms establish causation relationships in the data, in fact. It helps you detect patterns based on a complex phenomenon with dozens or hundreds of thousands of dimensions and columns. Data knowledge and expertise are always necessary, especially in the data preparation and the learning phases. The early stages, you need a business expertise. These algorithms need humans and human knowledge to build this intelligence. Deep learning is just a particular class of algorithms based on neural networks. This class of algorithms are very efficient and complex phenomena with not hundreds, but thousands or millions of columns of characteristics of features. And why is it a topic of interest? First, decision making helps you detect patterns in your data, fraud detection, classification, customer segmentation, make better decisions. The second interest is to enhance user experience, and we talked about this a little bit sooner with Waze or Netflix. It can also be about building chatbots, conversation between your application and your end user, your customer. In that particular case, we're going to use what we call NLP, natural language processing. These kinds of algorithms are able to understand, to get the intent of a user and perform an action according to this understanding. And it's also about image and voice processing. The last interest is about automation and augmentation, and I think I've just talked about it just before on the COVID-19 and the image processing. It could also be used for building surveillance autonomous objects, autonomous vehicles, for instance. And it's also a way to automate things, like a doctor could spend hundreds of hours per week to read new studies. These kind of algorithms can help a doctor summarize all these studies in a shorter document. So just to give you a few concrete examples. Machine learning is also a way to optimize things in your supply chain. In that particular example, it's about turnover optimization. It's about getting the good product at the good store based on your customer habits, past sales, based on customer historical data coming from your customer relationship management system, your CRM or ERP data. So it's a way to personalize again the user experience based on the customer characteristics and historical data, based on the list of products you can manufacture. The CRM or ERP can be augmented with machine learning to optimize your supply chain. Another example, totally different, is about harvest prediction. Same type of algorithm based on structured data coming from sensors on the field, hygrometry. So the goal was to predict for each land parcel and each type of parcel the harvest in tons. So it's a regression model where you can build a map predicting precisely your harvest and help you optimize again your logistics. You can imagine the savings and the optimization you can make with such algorithms integrated with your existing ERP or CRM. Another example is predictive maintenance. So predictive maintenance is about predicting an outage before it occurs. So you can also imagine the kinds of savings you can make by classifying each asset you have based on data coming from sensors, IoT data, for instance, real-time data. So you can use historical data to build your own predictive models. In that particular case, classification. Will it fail within the next 15 cycles, for instance? Or you can even build some regression models to help you determine the remaining cycles, so the time to live. Once trained, you are now able to predict an outage before it occurs and predict a scheduled maintenance, for instance, and save money. The last example is about augmenting your existing IBM application, the same as I mentioned earlier, but in that particular case, it was about customer churn. So this is an example of CRM running on IBM and not JS. And in that particular example, it's a way to provide to the lines of business additional information to better address each of my customers. In that particular case, it's about adding a churn scoring for each of my customers based on, again, historical data. This customer left, this customer didn't leave, and train these models on your IBM from your IBM data. Deploy this model in production, integrate it with your existing ERP or CRM. And at the end, you've got a scoring for each of your customers, being able to address them differently. So again, it's a way to personalize the experience and the way to address things instead of using averages and more or less precise models based on experience. So it's a way to automate all this. And you could do it right now on IBM. Just a few slides regarding machine learning. So what's machine learning? In fact, it's optimization algorithms based on statistics data sets. Basically, the input data have features, so columns. You see that on the top right of this slide. And the goal of each of these algorithms is to guess a column named the label. You see the top right column, decision, based on historical data and past data. So in the learning phase, each algorithm will try to guess the last column. And based on the error, we will correct these algorithms playing on parameters So at the next iteration, we expect to get a better result, and the distance between the actual result and the result obtained by the algorithm minimize this distance. So the key thing is to have a really clean data set as an input and output, so you are able to build a model that could guess precisely a value with new data. So each algorithm has parameters that will be adjusted during the training phase. So you have the choice between several algorithms. So based on your case, you have several kind of classes of algorithm that could be more efficient. And at the end of the training, you optimize this distance based, and you adjusted at each iteration the parameter values. So the algorithm is ready to get to be tested on new data never seen during the training phase. And then you can evaluate this model based on the error you get during this testing phase. Once validated by the lines of business, you can deploy this model in production and integrate it with your existing application. The model execution in production is called Inference. And of course, you can accelerate this training phase, because training phase is about multiplying big matrices and vectors together. GPUs, so graphical processing units, are very good at multiplying matrices. So GPUs or accelerator are really used when it comes to deep learning use cases with really, really complex scenarios. So image processing, voice processing, or very complex structured data processing. And just the last slide regarding machine learning internals. Even if you don't have to know all this when you use machine learning libraries, Scikit-learn, it could be necessary to understand the internals in general to do a better job. So as I mentioned earlier, training a model is about minimizing an error function, a cost function, at each or almost each iteration based on the data you are providing in input, the historical data. At the end, the goal is to minimize this error function, so the model, the algorithm, is able to guess the last column the more precisely as possible. And when you want to guess a figure, it's regression. You want to guess the number of cycles remaining for this particular asset, for instance, the time to live. Another class of algorithms are classification algorithms. Will this asset fail in the next 15 cycles? Yes, no. Binary classification. So different classes of algorithms, but same principle. You want to, during training, to minimize the error. Once this training phase over, you want to test using unseen data and validate it and validate this algorithm. Solutions. Many open source solutions, and first question is, will I do that on premises or using a public cloud? So we talked about Amazon, Azure, Microsoft Azure, IBM Cloud, Google. Can I do that based on regulations or based on the data gravity, I would say? So if you have terabytes of data that you want to use for the training phase, will you be able to transfer this data in a public cloud? Does it make sense? And then the libraries. So you have many open source, free open source technologies to help you build these models. As I mentioned earlier, you don't have to know all the internals. It's a good thing to know the internals and the math behind under the covers. But so it's a matter of choice. You can use SQL, you can use R, you can use Python and Scikit-learn, you can use H2O open source, driverless AI, which is a licensed product running on Power as well. Many frameworks, so PyTorch, TensorFlow, to build some deep learning models, neural networks. Do you need distributed processing? Do you need acceleration? Mentioned earlier, acceleration is often used at the training phase because they are good at multiplying big matrices. So acceleration is sometimes a topic of interest. And within IBM, we've got accelerating machines like NVIDIA JJX, Intel-based solutions, power-based. So we IBM have AC 922, the Power 8, the Power 9 based server with acceleration, building block of the Oak Ridge Summit supercomputer. So it's really a matter of choice. Relax. All you need runs on IBM I. So in that particular demo, I'm going to teach you how to get started on IBM I with machine learning. So this is the result of data science and analytics survey, Kaggle survey. So Kaggle is a really famous community website for every data scientist. And looking at the survey results, most of the technologies data scientists use are available on IBM I. So Python, R, SQL, Jupyter notebooks. So as you can see, you can easily get started with machine learning on your platform close to your data. And just to focus on the IBM I and AIX solution for data science based on free open source technologies, in that particular demo, we're going to talk about NumPy, Pandas for data processing, SciPy, Scikit-learn, Matplotlib, which are Python libraries to help you manipulate data, do some math, and of course build with Scikit-learn predictive models. But just for your information, you can also build chatbots with NLTK, so which is a framework used for natural language processing. You've got also Python, but R language as well. And of course more to come, hopefully. So everything you need runs on IBM I. For all phases, data visualization, data understanding, it could be just reporting visually, help you visually understand your data and do some beautiful charts and make you some fancy charts. It's about data preparation. As I mentioned earlier, during the training phase, training a model is like training to a child. If you give bad examples, the algorithm won't learn well. So you have first to clean up the data, making sure that your data set is really representative, and that if you observe a phenomenon, you want to make sure that the model will learn from the good data in general, right? So you can use machine learning libraries on your IBM I to work on your data residing on DB2.4i. But you can use also all this machine learning for model creation, training, and inference in production as well. In that particular demo, we're going to use Scikit-learn, which is the best of breed library to build machine learning models based on Python. This is what you need to get started with machine learning on IBM I. So a few packages, a few minutes to install all this using a yum install. Just to proceed with the demo, what I'm going to use in that particular demo, I'm going to isolate each of my users, my data scientists on IBM I in a shroud jail, so they can't impact each other when installing packages at a particular version, for instance. So each of my users, my data scientist users will be isolated on the platform using shroud. And I added an additional isolated environment for production. Once I trained and validated my model on the platform, I can easily copy this model in the IFS to the production environment on my IBM I platform, so I can execute the model for my future predictions in production. So these are the different steps. Model training, validation, model loading from the IFS. Once the model is validated, I can persist in the IFS. Then I'm going to load it on my inference system, which could be the same IBM I system, in my production environment, libraries, Pays environment. And I'm going to integrate this model with an existing application. So it's just an ILE to Pays or Pays to Pays integration. And you see on the screenshot an example of inference where I can easily score customers based on their characteristics. What we're going to use for this particular demo is a customer churn use case. Will my customer leave in the next month or not? Based on its characteristics, features, and based on the past data I use for training the model. So I know post-mortem which customer left or not, and based on each of their characteristics, I'm gonna build a model, predictive model on IBM I, so I can predict with unseen data new customers or in the future, and I can score each of my customers based on their current characteristics. And this is the Git you have to use if you want to replicate the demo at home.
So let's now proceed with the demonstration. So I'm on my IBM i 7.3 latest version of PTF. So I'm connecting through SSH to the Pays environment. I've already pre-installed the necessary packages and libraries in my Pays environment. So let's browse the IFS and go to the correct directory. This is where you should do a Git clone if you want to replicate this demo in your own environment. So this is the Git repository I'm using. So I've pre-created this Git. I pushed the content from my IFS to this Git repository. So now you can do the other way around, simply Git cloning this repo in your local integrated file system. So if you want to know more about the demo, you can have a look to this Git. There is online documentation. So the first thing I have to do right now, my packages I've pre-installed. So this is an example of commands I can use to upgrade, for instance, a Python package using the pip install tool. And let's now launch the Jupyter notebook. Jupyter is a graphical user interface to graphically, it's an integrated development environment for Python and R that can run on IBM I, on other platforms as well. So let's give it a try. So I'm launching this Jupyter Notebook server. This is the URL I have now to use to connect. So of course it's HTTP in that particular example, and I can switch easily to HTTPS if I need to. So let's connect to the Jupyter Notebook. So Jupyter server, I can browse the IFS from there, and let's choose a particular notebook. So I'm going to define what a notebook is. Um, a notebook, Jupyter notebook is in the Markdown format. Um, so it could be a Jupyter notebook is divided into cells. This is my Jupyter notebook, the one I've just cloned from Git, for instance. And this is a mix of cells, so coding cells and text cells. So you can mix documentation and code within a single notebook. In that particular example, let's type the pwd command, which is a shell command to know on which is the current directory. So if I type, so I can type shell commands Python or R. It's my choice, depending on the runtime I choose. And then I can start coding uh, from this web integrated development environment. Of course, once I'm happy with the code, I can export this code to Python executable, I mean, directly to be interpreted by the Python interpreter. But in that particular case, let's use Python and Jupyter with this interactive graphical user interface. So I've just preloaded the necessary libraries, matplotlib, scikit-learn, etc.
So let's execute all the cells at the same time. So I'm going to the menu, run all. So every executable cell will be executed. So we can then have a view of the result of each cell. So let's go back to the beginning of the notebook.
So let's load the data from DB2. So to execute this cell, I just have to press the Shift Enter, and I'm loading from DB2 the data into a data structure which is called a data frame from the pandas, so the Python pandas library. And this data frame is from this data frame I can manipulate the data from Python, and I will use it for using scikit-learn. So scikit-learn knows how to manipulate data frames. So I've just loaded the 7,000 rows from DB2, which are my examples, remember, for the customer churn scenario. So my customers with their characteristics, as you can see on the screen, I can display them using the display function. So this is data coming from DB2, loaded in a data frame in Python. And I'm going to use this data set to build my model. I can, before creating a model, I have to prepare and visualize the data to understand maybe a little bit more of the data. So this is, for instance, the example, a function to display a correlation matrix to identify features, columns that are correlated that could be useful to fine-tune the model afterwards. Or I want to maybe to use that to eliminate and do some dimensional reduction. So eliminate some useless columns that could be a problem or could be an overhead simply. I mean, from that, I am also able to change column types and encode some columns. In that example, I'm encoding I think it's the 18th column into a numeric value. I can also start preparing the data, not a number, so replace the not a number values by means, an average value. And as you can see right now, I can visualize some data, and in that particular example, I see a correlation between the customer tenure and the fact that this customer left or not. And of course, I mean, it's obvious said like that, but of course, the normally we observe phenomenon, and sometimes a pattern is determined by several columns at the same time. We can also visualize the data. So, I mean, it's not only machine learning. You can use scikit-learn, all the Python libraries to report, do some reporting, and display your data from DB2. I've just executed the cell, and as you can see, it just generated some bar charts. So it's a way to generate easily some reports from the data first. This function is used to determine the correlation again and understand the data. Um, is my dataset well distributed? So this is the data distribution. I have to make sure that if I want to create a model, I want to ensure that the data is well balanced. And for instance, if I have a list of customers and if there are 90% of men in my training data set, women will be underrepresented. And so my algorithm will learn badly, of course, because it's going to be biased. And in production, where we will have maybe half um, customers, women, and half men, uh, the created model will be biased, will get bad results. So that's why I have to make sure that my training data set is well balanced and well distributed in terms of values, etc. So I can again visualize and encode. So I can also detect outlier detection is about detecting anomalies in my data set. So example whose values are outside the range, I would say, a classic range of value. Maybe I want to keep them, maybe not. So some scikit-learn provides some useful functions to detect this kind of these outliers and anomalies in the datasets. So we can visualize, we can prepare, we can encode some values to numeric data, we can detect anomalies. So we can prepare the data on IBM itself using scikit-learn and all the Python libraries around scikit-learn. This is feature engineering, so I've just created additional columns to help my model to be more accurate. So this could be a mix of several columns with different formulas. So scikit-learn can help us generate this feature engineering um, process. And this is encoding. So as we just transform some values to the corresponding numeric values. So sometimes it was initially it was string values, as you can see. So the multi-lines column, for instance, is uh, is a string, is a character string, and we've just encoded these columns to numeric values because we need them to feed the models. Once I'm happy with the training, well, the data set, the entire 7,000 column lines, rows, examples, I can split manually this data set into a training, test, and maybe validation data set. So it's about, I mean, sometime, most of the time it's, I don't know, 70, 10, 10, or it could be 80, 20, if I want just 20% of the rows being used for the validation and test purpose, right? So in my case, 4,000 the rows for the training set, and the test will be around 2,000, as you can see on the screen. Um, my data sets is ready. So let's build a model, a classifier in my case, because I want to classify, remember, its classification, classify a customer based on its current features, classify them in a class. So 0 won't churn, 1 will live in the next month, right? So just I'm building an SVM, a support vector machine model.
Just launch the training. So training in progress.
So the training is done. As you can see, it's pretty fast. Um, So we could need in that particular example GPUs, but as you can see, the case is really simple, and even I mean IBM can manage this trading very easily. Of course, you can do it outside IBM, and then once happy with the model, you can import it in the IFS to be used in production using Scikit-learn for inference. In that particular demonstration, I'm training and inferring on IBM itself. So I've just trained the first model, SVC, so support vector machine, this classifier, basic classifier. As you can see, we used the X-train, which is the matrix containing my training dataset, and the Y scale is the encoded and transform Y, so the truth, ground truth vector, churn yes, no, based on historical data. Again, the training set contains characteristics of my customers plus the additional column, customer churn yes or no. Let's train a second model based on logistic regression, and then this is the multi-layer perceptron. So, up, I push the button for the trading. So it's different kind of algorithm, but same data. So it's trained, done. So it takes something like, 10 seconds to train this on 4,000 examples. And the more examples I have, the better my model is. In terms of generalization, its ability to generalize on new data. So as you can see, I can now select the model based on metrics. So it's in my particular case, this is a metric, the accuracy and the recall, which are two standard metric that can help me select the good model. So in my case, they are more or less equivalent: the MLP, the logistic regression, and the perceptron. So three models trained. Um, and as you can see, the accuracy is around 0.8, so it's better than luck, I would say, and so 80% of accuracy could be enough for my line of business to have this. This is a graph showing the comparison between several models, the three models I've just trained, and the more, as you can see on the screen, the perceptron seems to be the better one here, but it's really, they are quite equivalent, I would say. And the more I'm close to the edge, the better is the model is. Uh, so let's now test the model. So let's load new data in a test dataset, and let's infer, so execute the model. So in my case, I've just test with a single um, customer, and this customer is classified in the class 0, churn no. Then I can persist the model in my IFS. This is what I've just done using a Python command to persist the model with all the parameters set and fixed. So yeah, I can save it and of course load it in for inference. So let's load it from the IFS. And now I can really infer. So I'm testing it right now on 20 customers, new customers. And yeah, this is the vector saying this customer is classified in 0 or 1 because it's a binary classification. And for each of these new customers, I would say new customer data in production, I have the confidence ratio. And I know, for instance, the first one is classified in 1, and I'm with 72% of confidence. And same for each result. So the second is 0 so the first class 80%. So for each of my new never seen, I would say, unseen data in production. I'm now able to classify uh, each customer in the CRM with a particular scoring uh, to know, I mean, I can determine and I can address them differently based on this scoring. So this is pretty it. I've just described the whole process from the data visualization, preparation, and training on IBM. And as mentioned earlier, of course, you can also load data from DB2 and train your models outside IBM, and then for production, re-import the model, Scikit-learn model, for instance, and execute it in production next to my DB2 and my core business applications. I hope you enjoy this demonstration. Again, don't hesitate to contact me if any questions or remarks regarding this demo. And I hope to see you soon. Bye.